This lecture will explain how, once we have diagrammed our argument in a Venn diagram, how we can look at it and determine whether the argument is valid or invalid. So once you have diagrammed both of the premises in the Venn diagram, then you look at the diagram and ask the following question. Based on the diagram, do you already know that the conclusion is true? In other words, does the diagram show that if the premises are all true, then the conclusion must also be true? So let's look at how that works. So here's an example of a valid argument. Some mice are not pregnant creatures. Thank goodness. All mice are soft creatures. Therefore, some soft creatures are not pregnant creatures. So here is the form of the argument. And so we've diagrammed all M are S. That's right here. And then we have diagrammed some M are not P. So we want something in the M circle that's not in the P circle. And we know it has to go here because the other option is right here, and that's already been filled in. So then we look and we see if the conclusion is already diagrammed. So we never, ever, ever diagram the conclusion. Okay? You only diagram the premises, and then you look to see if the conclusion is already diagrammed. So the conclusion is some S are not P. So is there an X in an area that's in S but is not in P? Sure, right here. It's in S, but it's not in P. So this argument is valid, and we can tell just by looking at this X right here. Now here is an invalid argument. So no pink creatures are mice. Some soft creatures are not mice. Therefore, some soft creatures are not pink. So the form of the argument is here. And so we diagram that. First, we do the universal premise. So no P are M. That's right there. And then we have some S are not M. So we have two choices. Here's an area that is S, but is not M. And over here is another area that is S and is not M. And we don't know where it goes. So we put an X on the line here. Then we ask, is the conclusion diagram? Some S are not P. So here we have S that is not P. And we can see that this could be. So remember, this could have gone here. So some S are not P could be true based on this, but it could also be false because the X could have gone here. So the conclusion is not diagrammed because this is ambiguous. It's not clear. It's a thing that's S, and it's not M, we know that, but we don't know whether it's P or not. And so this argument is invalid.